get started. So what is CBTC? So according to IEEE 1474.1, the primary characteristics of a CBTC system are it's a high resolution train location determination mechanism, independent of track circuits. So there are no track circuits, there are no axle counters. It's basically the train determining its position and communicating with the wayside. 2, a continuous high capacity bidirectional train to wayside data communication system. Basically, you're communicating your position. The train is communicating its position to the wayside. And finally, train-borne and wayside processes performing vital functions, meaning you can transmit your position, but at the same time, whatever you're doing, it has to be safe. So that is the most basic definition of what CBTC is. So going into a little bit more detail, the first characteristic of IEEE says the primary difference between a CBTC and conventional is the ability to determine the position of the train independent of track circuits. So how is that done? Usually there are tags placed on the track. For example, in the diagram, we have A, which is a beacon, A, B, C, D, and they may be separated by a certain distance between them. It can be 100 meters, it can be 200, 300, whatever the designers decide they need. Those tags will determine roughly where the train is on the track. Course position is what we call it. From the beacon itself, as the train moves away from the beacon, the train-borne speed sensors or tachometers will determine the fine position, the distance that it's moved from the beacon, moved away from the beacon, say in this case 47.5 centimeters. Combining the two, the train-borne equipment will know that it's moved 247.5 centimeters and it will transmit that information to the wayside. So that's characteristic number 1. There are no track circuits, there are no axle counters. It is basically the train determining its position using tags and its own onboard speed sensor to determine its exact location. So that's characteristic number 1. Characteristic number 2 is once the train-borne has established its position, it needs to transmit that to the wayside. So it does that by using a communication link, a radio link usually. There's a radio on board the train itself. There are access points that are installed along the guideway. Could be every 500 meters, maybe every 1,000 meters. And the train will transmit its position to the wayside unit using this radio medium. Radio has become the technology of choice. Some suppliers use inductive loops, but radio seems to be the way that everyone is heading towards. So that's characteristic number 2, is to have a high capacity bidirectional two-way communication link where you can transmit where the train can transmit its location to the wayside. That's characteristic number 2. Characteristic number 3 is basically what it's saying is it's great that you determine your position. It's great that you can transmit your position, but it must also be safe. And IEEE has broken this down into 4 broad categories. Now, I've categorized these categories. IEEE doesn't say it. They basically list all the functions you have to do, but I've coupled them into 4 broad categories. The first is positioning, the ability of the system to track the train safely and be aware of where all the trains are within the system itself. Determine the speed of the train and monitor it. So if it's going, understand what speed the train is going at. If it exceeds the speed limit of the track, be able to stop it. Determine travel direction, routing, and interlocking functions, meaning this is your traditional interlocking functions, which is you set the route, the switches are locked for that train, and it's safe for that train to move along that portion of the track. And finally, IEEE talks about some miscellaneous functions such as work zones, door control, broken rail detection, grade crossings. Broken rail detection, that's debatable whether it's a CBTC functions, and I'll go into more detail in the CBTC building blocks. But this is characteristic number 3. It's saying that the CBTC system must be able to keep the system safe, protect the riding public, protect property, and protect the personnel that are maintaining and operating the system itself.